how you did. First of all, once you change it to y equals mx plus b form, 2, 4, 6, 8, you would know that your y-intercept is there at 0, 8. You know that your slope is negative 4 over 3, and we remember that slope is the rise over the run. A negative slope goes down from left to right, so I could go down 4 over 3, down 4 over 3, and draw my line as a result. Now, if this was a test or a quiz or the exam, you would lose some marks on this because we haven't labeled anything. There's no scale given. So sometimes it's nice to label. Maybe I label my y-intercept there. Maybe I label my x-intercept there. And now I have scale. So we need to label some things to give our graph some scale. Now what we're going to look at is we're going to look at equations like this blue one. 4x plus 3y is less than 24. Now I'm going to tell you, there's a ton of different answers that make that true. Can someone tell me a point that makes this true? And can someone tell me a point that makes it false? So, for example, you can pick any point anywhere. What do you find?
0,
0, 0. That's this point right here. 0, 0. Is it true or is it false? If you plug in 0 for x and you plug in 0 for y, is the statement true? Yes. Because 0 plus 0 is 0. Is 0 less than 24? True. So 0, 0 will go on the true side. Okay, another point. In fact, I don't care if it's true or false. 6, 1. Is it true or is it false? Okay, this will be 24 plus 3 is 27. Is 27 less than 24? No, 6, 1 is false. I like color coding stuff. I somehow feel like true and red conflict. What color for true would you like to go with? Green? Blue. Blue? Oh my goodness. I've got these options.
We're already reaching for the graph.
Black. Black is so... You've already got green on the graph there?
Ooh,
Chartreuse.
maybe you choose
Chartreuse. Orange.
No, that's scary.
red. Let's
Orange? No, orange is too close to red.
Let's go for a teal.
No, teal? So it's too much options. Ooh. That makes me quite happy. Does that make anybody, like...
That does spark joy.
I'm gonna... But we have an issue here. I like that color. How am I going to remember that color? Okay, I'm going to... I don't like this pen anymore. I'm going to make it solid. I'm going to make it... I have to see if I can refine that. This is wasting too much of this video. A little bit brighter than that?
Oh yeah, there is an eyedropper.
Light is good. Get rid of that red dot. We had... Yes. Oh, it's thicker than I like. I'm going to be okay. We could spend all day making it the perfect pen. But 0, 0 is true. And we just found 6, 1. And we said that one was false. Okay. Find another point. Tell me if it's true or false. 2 and 3. 2, 3. If I plug in 2 for x, that's 8. 3 for y, this will make 9. 8 plus 9, 17. Makes it true, right? Okay, I'm sorry. That's bothering me. Too thick. 2 and 3. There we go. That point's right there. It's true. Another point. 5 and 1. So 5 and 1, this will be 20. Ooh, plus 3. It's so close to not being true, but it's still true. 5 and 1. Right there. Awesome. Okay.
1 and 5.
1 and 5. 4 and 15 makes 16. That's another blue one. 1 and 5.
5 and 5.
5 and 5.
That's cool.
20 plus 15, 35. That'll be false. 5 and 5.
3 and 2.
Okay, now you just want to keep guessing points to see how long you can make me do this. But now I'm going to put, okay, I'm going to draw a big purple point, like really big. Whew. Okay, as quick as you can, tell me true or false.
True. False. False. True.
So I'm putting the point somewhere, and you have to tell me, do all the mental math quickly.
How?
Oh, that's a good question. How are they doing it so quickly? What about this one?
True.
How did they do that? They're amazing.
False.
Oh.
What?
True.
Make you think a little bit.
False.
False. Good.
I guess the center of it would be true.
They're noticing a pattern. What pattern are they noticing?
If it's below the diagonal line, it will be true.
Anything in this area will be true.
Why?
Why? Because this is the graph of the line that's shown here with an equal sign.
Oh.
And we're wanting to find all the parts that are less than. In fact, we could rearrange this inequality a little bit.
Okay.
So I'm going to take this inequality. I have 4x plus 3y is less than 20, not equal to, is less than 24. I could move the 4x over, and I could divide by 3, and get my y equals mx plus b, the same as I have in black, but now instead of an equal sign, I have a less than sign,
Okay.
which says that my y values always have to be less than the line. You can take any point on the line. Here's the point 0, 8. And if I take all the y values less than, big arrowhead here, less than would be below, right? And if I always take things below the line, I'd have to shade underneath. And we noticed when we picked points to check, every time we picked a point in this blue section, it fell under the true column. But anytime we picked a point above the green line, it fell into the false section. So sometimes a solution to a problem is millions, an infinite amount of answers. You're never going to be asked to, hey, can you just write down all the points that work? That would be fun, right? Write down all the points. Well, there's an infinite amount. Yes, and do it in alphabetical order. Right? Really confusing. How would that happen? It wouldn't work very well. So what we have is we are going to be graphing and solving linear equalities with graphs, and the way that we solve them is with shading. So first of all, we're going to write a little bit of notes off to the side that are going to be helpful for us. So just in the column on page 355, if you see this, do you think you'll shade above the line or below the line? Above. Because you need your y values to be greater than and because there's no equal sign, we will draw a dotted line to show the line isn't included. When you have the equal sign, you will still shade above, in this case. Wow, that's sad. Sad. We'll still shade above. But this time you will draw a solid line. So technically in the one that we just did, I should go back and this is what the actual solution should look like to that inequality. You make the line dotted to say, that's not part of my solution. It's just the shaded part below. So when I put the big purple dot on 0, 8, you guys were true in saying that's false. I'm messing up words like crazy today. And then opposites would be if you see this sign, which is less than, where are you going to shade? You're going to shade below. And solid line or dotted line?
Daughter.
Dotted because the equal sign is not there. And of course, just to finish everything off, we have this one. Shade below, but draw a solid line. So this is if you have the y by itself, this is a shortcut for deciding where to shade. In the one that we looked at, our we rearranged to get y by itself. Here it is in the blue box, and we had y is less than. So we could take any point on that line and shade below, and that's why it's underneath the graph, okay? They'll also tell you that if something is true in a region, everything is going to be true in the region. So what we did to begin with is you actually found 6 test points, is what they're called. You plugged in 0, 0. Did it work? Yes. And since this point worked, everything in that whole area could be shaded and you're done. So you could find one point that works and then say, okay, everything in that area is good, I can shade it. I usually recommend 2 or 3 test points, because if you try one test point and you make one mental math error, that usually adds up to one big error in your shading. You shade the whole thing wrong because you made one mental math error. If you try 2 test points and they both are in the same area and they both work, chances are you didn't make 2 mental math errors in a row. You're probably right. We did 6 test points. We found 4 that worked. They were all in the blue area. We found 2 that didn't work. They were all in the other area. So you can either, if you get y by itself, you can use these as shortcuts, or we can use test points. So here's our first example. Oh, I like this example. First of all, if you're going to want to graph the line, often it's easiest if you have it in y equals mx plus b form. So I'm going to move the x over to the other side by subtracting x on both sides. What would you prefer? I make a mistake in my next step, or I don't make a mistake in my next step? You want me to make a mistake?
Yeah.
So I'm going to make a mistake. Don't write this down yet. I'll do it in red because it's a mistake. I'm going to divide everything by -3. That would make this positive. I can write that as 1/3. Ooh. And this divided by -3 actually would become -2. And now you have to say, well, what did he do wrong?
inequality.
Right. So do you remember from previous years, in an inequality, if you multiply or divide by a negative the inequality changes. Sometimes teachers say it flips. So the right answer, which we can use a beautiful blue pen to show, look at that. You would, because I'm dividing by -3, this will change. This still becomes 1/3 x, because a negative and a negative become positive. And I would have x divided by 3, but that's the same as multiplying by 1/3. Kind of nice, because that's my m, or my slope. Minus 6 divided by -3, -2. So that nice blue is the correct answer. And now that we have y equals mx plus b, it becomes fairly easy to draw. I would start by labeling my y-intercept at -2. And I have a slope of 1/3. That means a rise of 1, a run of 3. A rise of 1, a run of 3. And those 3 dots are going to be on my line. Technically, I should label another one. Maybe I'll label 6, 0, my x-intercept. Do you know what's going to happen to you a lot? Oh, it already happened to Hunter. Did it happen to anyone else? Okay, oh, it sort of happened to Nikita, right? What are you used to drawing when you draw a line? You're used to drawing a line. But is this one a line? No, it is the dotted line one. Because there's no equals, you have to do,
It's still a line,
it's still a line, but it's a dotted line. I usually have an eraser in this unit for this particular thing, because I will be like, there's my line. And before I know it, I've drawn my straight line. I'm like, oh, has to be dotted. So I take the eraser out and just erase little bits of it. Where will we shade? Above or below? Okay, someone had.
Can you go back to that slide where you put up the thing about the
I can, just wait, give me 1 second here, because I think everything is frozen temporarily.
You shade below
Because it says y less than. Okay? But yeah, currently it is, computer is frozen. It is not responding. Oh, there we go. I was. If I hit this button, I can steal a color from somewhere else. I hit
You
this
hit that
button,
button, then you hit the color you want.
and then I hit the color right here. Did it do it?
Yep.
And I'm gonna save it. Nice. Our new favorite color is now a crayon for shading. Very nice. So now, we draw our line, we make it dotted because of the less than sign, and then we'd have to shade below. Now, just a review from grade 10, changing to y equals mx plus b, great way to draw a line. Very helpful, gives you your slope, gives you your y-intercept. But if you're like, I don't remember, or I'm worried about changing something, lines are always straight. How hard is it to find 2 points on that line? Not very hard at all. So you could just make a little table of values and say pick any x value you want. And I'm going to start with the original equation. I'm not going to move things around at all. So if I started with my original equation, I said if y is 0, I can pick something for x or something for y. If y is 0, what's x? Well, 0, negative 6 plus 6, x would have to be 6. We could find points this way as well. You could plug in another value. Now, some of them might end up with fractions this way. It's kind of a nice thing about y equals mx plus b. It usually finds you nicer numbers. But some people like to find both of their intercepts. You could just plug in 0 for x. Then you'd have negative 3y and 6. Solving for y would be negative 2. And you would find these 2 points in a different way. If you have 2 points, can you draw a straight line? Yes. Now, if you had used this method, your y would not be by itself, and you couldn't use the idea of shading above or below. But let's pick a point. Pick a point anywhere on the graph, right? You could choose pi comma pi. How is that for your mental math? Right? Is it, it's doable, right? But sometimes we choose values that make our mental math a little bit easier. Like, I actually think pi is not too bad, pi comma pi. Can you see that this would be 6 minus pi on this side? And this would be negative 3 times pi, about negative 9. Is negative 9 greater than about 2.8? False. So, okay, there's your pi comma pi point you found to be false. I would not recommend choosing pi comma pi, because the mental math is not as good. What would be a nice mental math point to choose?
Negative 3, 4.
Negative 3, 4 probably would be better than pi comma pi. Other choices? 0, 0. Like, you want your mental math to be crazy easy? Choose 0 and 0. Look what happens with the original equation. If I choose 0 and 0, this side is 0. Last time I checked, 0 was not bigger than 6. That point's right there. Now we have 2 test points that failed in the upper section. So when you would go to shade it, if you had found your 2 points, drawn your dotted line only with those 2 points, now your test points say don't shade above, we're going to need to shade below. Okay, so questions for practice. I'd like you to circle 3, 4, 5, and 7.